Question number 36. An aircraft moves from point P, 45 degrees north, 70 degrees east, to Q, which is 60 degrees south, 70 degrees east. What is the distance covered by the aircraft to move from P to Q? Take 2 pi r to be equal to what? 45,000 kilometers. All right. So I'm going to sketch this point on our map, on our wall map, or on our sphere. All right. So now the aircraft moved from point P, which is 45 degrees north. The first degrees here stands for the latitude. When we talk about latitude, is these other circles that moves from what? West to east, or east to west. East to west. This is east to west, and then north to south. 45 degrees. So 45 degrees, this is the center, the equator. So 45 degrees is somewhere here. So we rule that line there. So permit my straight line. Let me draw something a bit neat. Okay, this is the center to that point. Okay, 45 degrees. All right, and then the longitude is 70 degrees. This is the longitude, which is already there. So that's our point P that we just located. This place is our point P. Okay, so now let's locate our, let's look at the second point, which is Q. You know what I said? Latitude 60 degrees south. So this is the center. Latitude south, you come down. So this is south, 60 degrees. Let me sketch that. Latitude 60 degrees. Latitude 60 degrees. Okay. And then the longitude, this thing, angle is still 70 degrees east. So you see the longitude of the first point is the same as the longitude of the second point. Longitude is this vertical circle line that cuts across from north to south. That's the longitude. So you see that the 2 points have the same longitude. They are on the same longitude. So this is point Q. You see, they're on the same longitude. So here is your angle that you call theta. Okay. So we've been able to sketch out those points on our sphere. So the question now is, what is the distance covered by the aircraft to move from P to Q? That's to move from here to here. So basically, look at what we are looking at. Permit my drawing. And this is your P, and this is your Q. Here is your theta. And then this here, this line here is your big R. Is your big R. If it is on latitude, this thing, it will be small r, but here this is a longitudinal angle. So it will have the radius of the Earth, which is big R. Okay, so we've sketched that. So we are told to find the distance covered. That we are told to find this length here. We are told to find this length here, or this arc here. Okay, and the formula to do that is length of an arc is theta over 360 times the circumference, this longitudinal circumference, times the circumference of the circle, which is 2 pi big R. Then, however, how do we determine our theta now? That's the angle between the 2 points. Now, this is a longitudinal angle, in which the difference is found in the latitude angle. You understand? That's the variance is found in the latitude angle. So, theta, erase this. So, our theta will be equals to, since they are on different latitudes. I mean, since they are on different latitudes, that's the first latitude is in the north, 45 degrees north, and the second one is in the south, 60 degrees south. So we add them since they're on different latitudes. So we add 45 plus 60. 45 plus 60. And that will be 105. 105 degrees. So the angle between the 2 points is 105 degrees, since they are on different latitudes. See, point P is on this other latitude here, while point Q is on this other latitude. So since they're on different latitudes, that's north and south. If they were north or south, we subtract the angles. So this is it. So therefore the distance covered, distance D, which is the same thing as length of this arc, which is the same thing as length of this arc, 105, will be what? 105 divided by 360 times 2 pi r. Already we have been given from the question that we should take 2 pi r to be what? 45,000 kilometers. So we write 45,000 kilometers. So the distance covered would equals to, if you calculate that 105 divided by 360 and times 45,000. That will give you 13,125 kilometers. Give you 13,125 kilometers. So the answer is A. So the answer is option A. So this is how you solve this spherical problem that has to do with bearings, or that has to do with distance and space. All right.